Hello students. So what we're doing in this video is the work and energy lab. So I'm going to outline what's going on and then we're going to start taking some measurements. First is you get to meet Science Box. This is a lab quest. You might have seen this in your other classes. It's just a machine for making measurements. In this case, it's measuring the position. What we're going to do is use this to get our data. Right now, it's hooked up to this ticking sensor. This is a motion sensor, what's called a sonic ranger, because it tells you the range to an object. We're going to have it set up here at the top of this ramp that's on an incline. You can see the incline. We're going to measure the incline here in a minute. But what we're going to do is take one of these carts, and we're going to roll it down the ramp. Now, you might notice that there's tape marked out here. This is where we want to start. This is where we want to start measuring. And down at the other end is where we want to stop measuring. And the places where we measure are going to be a meter apart. So if I put a rule, if I put my cart here, I know there's about 3/10 of a meter. And I can't get too much closer because then the sensor ends up not reading the distance. But I know that if I get to about there, that's 3/10 of a meter away from the sensor. And so our measurements are going to be 3/10 and 1.3 meters. So we also need to know the mass of these. And last year I weighed these out. This is 0.5143 kilograms. I did this for the momentum lab, but it's going to come in useful here. So we're going to drop this down, and then we're going to do it again where we attach blocks that are about 0.5 kilogram. So we're going to constantly be increasing the mass of this cart. Now the measurements aren't going to take much time, I don't think. We got to measure the angle of this track, and we got to measure the mass of the carts, and we got to measure the positions and the velocities at these two positions. But what we're going to do is use this thing to tell us those positions. So it's not going to be too bad. So on here, you're going to calculate. You've got where you got to calculate, your positions and velocities and your displacements. And then you're going to calculate, in one calculation, the change in the kinetic energy. The other thing you're going to do is go and consider the forces and ask, what is the work that gravity does on this object, on this cart? And so you'll have 3 different tries to do this, for 3 different masses. And what you should find is that the work that gravity does should come close to the kinetic energy change. But the idea is that there's more forces here than we're accounting for. In the lab, I ask you just to account for gravity and the normal force. And if you remember from other places in our discussions of work and energy and forces, the normal force is always going to be perpendicular to the motion of this thing. If the cart's being supported by the track, then the normal force is always going to be slightly up at an angle. It's 90 degrees to the track. And that means the work that's done by the normal force is 0. It cannot be actual work done by that normal force. So when I ask you to calculate it, I'm asking you to show me that it's 0 once, and then go ahead and just find the work that gravity does. So you may have some issues with calculating this. The cosine theta is the angle between the work and the displacement. The displacement is down the track, and the force is going to be, for gravity, straight down, and for the normal force, perpendicular to the track. So we're going to set this up and take some data, and the very first thing we need is the slope of this track. So I'm basically just going to call the numbers out here. But I'm not going to give you the angle. I don't know what it is. But what I can do is measure. And what we're going to do is measure from point of support here down to the point of support at the other end. And if I do that, what I can tell you is that it is, let's go with 1.78 meters, 178 centimeters. And this is going to be the hypotenuse of a triangle. Now, the other thing I can do is measure, excuse me, got my 2 meter stick, I want to put a light out, measure to the point of support here. And what we can see is that that is 16.5 centimeters. Right. So what we have is a triangle. Right. You should be writing this stuff down. We have a triangle at right angles here. This is 16.5 centimeters. This is 178 centimeters. And this will give you this angle theta, which is actually called phi in the lab book. So you can calculate your phi. Now, again, we're going to go and say this mass is 0.5143 kilograms. Go ahead and keep 4 sig figs until the end. Okay, so 0.5143 kilograms. So what we're going to do is set up to do the measurement, wake the computer up. All right, and it'll take some measurements. And we'll have a graph. And what I will do is just call out the appropriate numbers at this. All right, so we have a graph, and if we want, we can go look at the actual data table. I hope. Pause for a moment. Okay, I had to go get a new lab quest because that thing was being stupid. But, all right, we have a graph. I can read off the numbers. We can look at the data table so we can go to exactly the points we want. We're going to use 0.3 and 1.3. We're going to get the position and the velocity, and we're going to ignore the acceleration. Though it might be useful to note if you happen to glance at it as we're doing this. So we're going to do these measurements. We're going to do 3 of them, and we're going to take our data. All right? So the other thing we're going to do is, we're going to start it up here. We're start it at the same spot every time. And we're going to keep our hands out of the way otherwise. Or roughly at the same spot. All right, so here goes the first go. I'm going to let it run for a second. We don't care about the time from when we started. We care about how the distances it covers. So we're not going to worry about time. I'm going to start it and then go. And then it'll run for a while. All right. All right. So if we look at the graph, we got a graph. That's kind of what you expect is some acceleration, some constant velocity. That works okay. All right. So now if we go to the data table, okay. So our problem here is it's not showing the, oh, that's the problem. I'm reading the wrong column. So this is another thing. It's not going to tell us precisely the correct number. So we're going to have to get close to it. I don't know if you can see that. So when I read these off, It's not going to be perfect, but it's going to be close. All right. And so this is for, and we don't have to know the precise mass immediately, but it would help. So this is for the small cart. Our first position is 0.305 meters. And our velocity is 0.564 meters per second. So I'll show you that. 0.30, focus. 0.305 meters, 0.564 meters per second. And that was the first point we looked at. And now we're going to go to 1.3 meters. And we're going to take the closest one, which is 1.291 meters and 1.501 meters a second. So we'll have 1.291 meters and 1.501 meters per second. All right, so we're going to reset for a moment, and then we'll do the experiment again with more mass. Okay, so this is our second cart. The first cart had mass 0.5143 kilograms. The second one is going to have this plus 0.5312. And so if we add that up, that'll be 3 and 2 is 5, 1 and 4 is 5, 3 and 1 is 4, 5 and 5. So this should be 1.0455 kilograms. 1.0455 kilograms. And mark it one more time. Number 2, 1.0455. All right. So we're going to run this again. And again, we're going to do the same thing. We're just going to run it, and then we're going to measure our data from our graph. So here we go. Come on. There we go. All right. So we look at our graph. Our graph looks pretty good. All right. You see the red line is the position, and it is a nice sort of parabola until it gets to the end of the track. There is a point where the sensor can't see the cart anymore. But it's not where we're measuring. And in the velocity, after a while, it jumps because it can't see too close, and then it's a nice straight line. That's what we expect. So we'll look at the data, and we'll scroll, and we scroll, we scroll. All right, so our first data point is going to be 0.313 meters and 0.569 meters per second. See if I can highlight that. I don't know if that will come in. It's the highlighted line. 0.313 meters, 0.569 meters per second. And then we're going to go and get our second set. And we're kind of, we don't have a lot of choices here. Here we have 1.325 meters, 1.537 meters per second. That is 1.325 meters and 1.537 meters per second. And maybe it would do well. All right, so maybe if you like a different contrast. All right, there's our data points. 1.325, 1.537. So we're going to pause, reset, and do it one more time. Okay, we've assembled the cart again. This time we are adding 0.5323 kilograms. You don't have to know that particular block. What you do have to know is that the total mass of the cart is 1.5778. 1.5778. And I'll hold this here. That's what you should have so far for your data. Okay. Hopefully that's all in focus. It looks good to me. All right. So we're going to run this one more time and take data just the way we've been doing it. This shouldn't be too big of a thing, but we'll see. You do have to be careful when you adjust these. All right, so when I set it here, I'll make sure it's on the track correctly. So we're going to start it and then let it go. And you heard that there was a disaster at the other end of the room, but that's okay. So we check our graph. Everything looks good in our graph. And we're going to look at our data table. So when you're in lab doing this in person, there's these symbols up here where you can pick out what you're trying to do. And it's kind of obvious what you need to do here. All right. So this one, we're going to take above the highlighted line where it says 0.0292. That's going to be our close number. So 0.292 meters and 0.555 meters per second. I'll repeat that, 0.292 meters, 0.555 meters per second. And then we scroll down. All right. So here, unbelievably, it's getting spread out as it seems like this is happening faster somehow. So we'll take 1.277 meters and we will take, what's the other number? 1.506 meters per second. Now, of course, there's probably some error in these measurements. Right? Is it this thing has some limited sensitivity. We can't be absolutely certain of what's going on, but we at least have some data. Right? So here is the data you should have. Hopefully everything's visible and legible. Right? The cart mass is in kilograms, and it is to at least 5 sig figs, or at least 4 at the first one. And then all these are in 3 sig figs the rest. Right. And I'm holding that there for a while, but you should pause the video and read these numbers off and fill them in. Okay. Of course, if you have a question, you can feel free to email me. I'll have this, basically you should be able to get the data from this video. And it takes a while to reset, but, this is experimenting. All right, so that's going to conclude the video because everything else is stuff that you need to calculate on your own. Okay, so we're going to come back and do momentum next. It is 6 p.m. and I'm still making videos, so we'll do this as long as we can. I'd like to get them all done today, but one of them is going to make me sick. So we'll see how it goes.